Hello, my name is Wilpan Chenseng and number matrix 106700. Today, me and my group mate will present our presentations about Google Glass for subject TMF 1003. So, for the background information, eyeglasses have advanced from simple vision aids to high-tech devices. Initially rare and handheld, they evolved into practical wearables with the addition of temples. Modern innovation include augmented reality (AR) and artificial intelligence (AI)-powered features, making eyeglasses multifunctional wearable tech. Google Glass, for instance, offers real-time interactions, hand-free navigation, and personalized content. Future developments focus on enhancing comfort and seamlessly integrating advanced features into stylish and comfortable design. Let's address the problem statement. Google Glass faces several challenges such as limited battery life, fragility, high cost, and bulky components. These factors reduce usability and appeal. Interaction methods like touchpad and buttons compromise hands-free convenience. Therefore, we aim to innovate with a focus on durability, energy efficiency, and user interaction, all while ensuring a lightweight and
Good
stylish
morning,
design.
everyone. My name is Lai Kaichi, and today I want to introduce cause and effect chain analysis for Google Lens through three systems: subsystem, supersystem, and system. Firstly, we talk about the supersystem. Google Lens started with Google Search and basic AI tools for processing image. Over time, it integrated with tools like Photos and Assistant to perform a task like object recognitions and text translations. In the future, it might use AR and VR for even more connected experiences. Next, we talk about the system. Google Lens transformed glasses from basic vision corrections to into smart devices powered by AI image recognitions, offering instant insight. Future versions, like the potential Google See, may combine AR displays and voice control for immersive functionality. Finally, we talk about the subsystem. Basic lenses and frames involved into advanced components like camera, microphones, and AR capability, all driven by AI. Future subsystems could feature quantum computing and highly sensitive sensor for enhanced interactivity. In summary, Google Lens evolved from simple tools like Google Search and early AI into an advanced system integrating AI, AR, and real-time features like object recognitions and text translations. It transformed glasses from basic visions and into smart devices with advanced subsystems like camera and AR capability. Looking ahead, technology like quantum computing may further enhance its capability, offering even more immersive and connected experiences. These evolutions not only highlight the rapid advancement of technology, but also showcases Google Lens' potential to redefine how we interact with information and our surroundings. By seamlessly integrating smart features with everyday tools, it bridged the gap between physical and digital world. As these innovations continue, Google Lens could become an essential part of daily life, empowering users with instant insight and more efficient way to engage with the world. So that's all from me. Thank you.
Hello, my name is Luigi. I would like to continue the presentation and talk about the function analysis of Google Lens. First and foremost, component is an identifiable object that make up a part of an engineering system. Component can be substance or fields. Substance is defined as an object with rest mass of such as table, book, hammer, and nail, while field is defined as an object without rest mass that transfers an interaction between substances, for instance, magnetic field and electric field. For the component analysis of Google Lens, there are many subjects able to be found from it. First, frame of Google Lens provides support such function which is holding hardware component. Second, optical display provide display function which is displaying argument related content. Third, the camera is used to take photo and record video. The touchpad allows the user to navigate and operate the system. For the microphone, it can input the sound while the speaker will output the sound for audio feedback. The processor plays the most important role, which is computing data and controlling application. The battery, which is power source, supply energy to all components. The sensors are used to track the motion, orientation, and light level. The last component is connectivity modules to help the Google Lens to connect the Wi-Fi, Bluetooth, and GPS network. Interaction analysis is an analytical tool that identifies and understands the interaction between the components of the engineering system. From this interaction analysis, we can further frame how all important components, which are microphone, speaker, battery, processor, touchpad, connectivity module, sensor, optical display, and camera. Last but not least, module is an analysis of the interaction between components of the engineering system and super system. It identifies the advantage and disadvantage of the function acting on each of the component. From this function model, we can find that user play the role of holding the heads and operating the Google Lens. Besides that, we can also find that camera need the supersystem component light to capture the image of environment. Thank you for your listening. Now, I would like to pass my duty
Alright,
to the
hi.
next member.
My name is Mio Daniel Azizan bin Mio Yahya, matrix number 104942, and I would like to present about trimming. So for our trimming approach, we will have three, and that is trimming the frame, the battery, and also the touchpad. First of all, the frame adds weight, restricts style, and is also uncomfortable for prolonged use. So the solution is to remove the frame entirely and integrate a display module. Secondly, we use the batteries. Batteries increase weight and it limits operating time. So we make a solution for it to become solar powered. And lastly, the touchpad disrupts the sleek design and overall requires manual input. So we replaced it with voice commands, eye tracking sensors, or just general gesture controls. The core function of Google Glasses is to provide augmented reality overlays, notifications, and real-time information through a heads-up display. Basically, your phone inside of your glasses. So this is our trimmed model. As you can see, we already cut off the frame, battery, and the touchpad, and we replaced it to make the solution as you see before your eyes. So making it more streamlined and doesn't actually hinder the progress of the product. And this is the diagram of our finished solution.
Hi everyone, let's talk about addressing engineering contradiction using the example of Google Glass. The contradiction occurs because if the Google Glass had better battery life, then it is more reliable for users. But the weight of the Google Glass is double. To solve this contradiction, we can use inventive principles, which are guidelines for problem solving. First, taking out. Removing unnecessary components to make way for a larger battery life without increasing weight of the Google Glass. Next, self-service. Provide user replaceable batteries. This means users can replace the battery themselves. The following inventive principles, that is, aesthetics and economics. These focus on creating Google Glass to be lightweight and more comfortable to wear. By applying these ideas, we can improve battery life of Google Glass without making the device too heavy or uncomfortable to wear. That's all
Everyone,
from me.
my name
Thank
is
you.
Vanessa Michi and Adoni. Today I'm gonna talk about the contradiction metric. The topic is about Google Lens. If we improve the lens become more modern and advanced, then it will make it easier for users to access the Google Internet anywhere and anytime they want or they need. But of course, it is easy to break and damage. It is also expensive. Not everyone can afford this. For the improving parameter, I will choose parameter 28, and for the worsening parameter, I will choose 27. For the intensive principle, it will be 3, which is 1, 15, and 35. Okay, principle 1, there is segmentations. The explanation is we dividing a system, object, or process into a smaller, more manageable part to improve the function and more flexibility, which user can take off the glass from the frames to make it easier for them to keep it safer. This way can avoid the glass from breaking and damage the lens. And the second one is 15. There is dynamite. This principle make the system more dynamic by enabling it to adjust the behavior based on external condition. Okay, and for the last one, I have principle 35. There is parameter change, um, which is instead of using plastic and metal to make the frame of the spec of the glass, we can improve it by using the rubber to make it more flexible for the user. This can help user to keep the glass more easier without them worrying about it breaking easily. That's all from
Next,
me.
we move on to enhancing the functionality of a Google Glass. The function is to improve focuses on augmented reality, AR, clarity, and better user interaction. The generalized function aims to enhance visual output and intuitive control for wearable devices. Our new product idea, Google See, features innovation like micro LED display, AI-driven content and customization, gesture control, and improved battery life through solar charging or graphene battery. Addressing secondary problems, we tackle issues like limited battery life and user experience. Ensuring better performance for extended Next is for the multi-screen. In the past, the focus was on using Google Search and early AI tools with optical glasses featuring simple lenses and frames. In the present, the system is more advanced, integrating the Google ecosystem supported by AI and high-speed internet. Google Lens, powered by AI image recognition, includes camera, touchpads, battery, microphones, and cloud-based AI. Looking ahead to the future, we envision technologies like AR, VR, IoT, and smart glasses such as Google See with an integrated display, GPS, quantum computing, and highly sensitive
Okay, next I would
sensors.
like to also present about T and S curve. So the S curve of our product glasses is the evolution of how glasses were actually made and come to into our modern times. So as we can see from the past, it was very rare to come by as the resources were hard to be built, and it was very inconvenient because there were no handles, so you had to use your hands. And then for our second picture, it's about the growth. The design made was more accessible due to the invention of temples, so you didn't need to hold it with your hands anymore, and it was becoming easier to come by. And then thirdly, it progressed into our modern age, and that is now where it matured and is easier to come by. Lenses are easily interchangeable if you were to poke it out or lose it somehow. And there's more variety of design, and it's not bulky, so it's more sleek and easier to be, and it's portable. And then lastly, for our future and the final evolution of glasses is our project itself, and that is Google Glasses, where it's a wearable computer glass that tries to bring connectivity and functionality that we all enjoy in our phones or digital devices inside our frames or lenses. That would be